All right, well, welcome to today's Accendo Reliability webinar. This is one in an ongoing series I'm titling Fundamentals. And the intention here is to create a series of webinars that cover the basics, the fundamentals, essentially, and some basic definitions, some basic insights and starts. And the intent is to eventually bundle these into a series of recordings that are available for those looking for the basics, for the starting places for many of these different tools. As many of you know, up on Accendo Reliability, we've got lots of articles and other material that's related to these topics. And I'm intending to build out the pages instead of just a webinar recording or the audio of this goes into a podcast, is also include all of those other reference materials and links that are in the body of work that is now the Accendo Reliability site. I don't know that we have all that much on hazards analysis. I do remember doing a podcast on speaking of reliability with Carl on it. Yet I'm sure there's one or two other articles there too. I got to do a little bit more research to find that. All right, so welcome everybody to today's webinar, and let's get started. I remember years ago, I was talking to a retired chemical engineer, and he was called in to do expert witness work on a regular basis. And I asked him once, why are you so busy with all of these legal cases? You seem to be working more now than you did when you were working full time. And he goes, well, he says, I don't understand how anybody can bring a product to market in the US. We're such a litigious society that if there's any hint or any problem with a product, not that it doesn't work, but that it causes harm, or it's even if it's used inappropriately, there's so many ways a product can cause problems. Now, I by no means am trying to display lawyers and our legal system in the U.S. as a crocodile in the water. Yet it's one of those things that is part of doing business in some parts of the world, especially here. And they're just looking for something that goes wrong with a product. It's not designed correctly. It's not operating such that it fails safe, or it doesn't have appropriate warnings, and so on. The issue is that everything, whether it's a tree in my yard or a crocodile in the river, there's danger out there. Now, some of these dangers are inherent, and we know about them. If you're going to go swimming off the Farallon Islands just outside of San Francisco, it's known to have great white sharks. And it's not that you go out there just for fun. It's quite a trip to get there, and it's really, really cold water, so it's not a South Pacific island or beach resort kind of place. But there are places in the world, and there are products that we produce that have inherent dangers. I mean, think of your kitchen. Um, you probably have one or many knives, and some are intended to be very sharp. Used improperly, or just dropping one, you have to remember not to try to catch it with your foot if you drop a butcher knife. Um, if I drop something in the shop or in the kitchen, I often try to buffer that fall. Although I've been lucky and not had to try that with a knife. There's an inherent danger with some of those things, and so. But our products serve a purpose. They serve some benefit or some utility of what that function is, what that product is actually trying to do. So let's see, TChem, I notice it might also be my voice. I know I've got a little tickle in the back of my throat. So how's it sound to everybody else? Hopefully it's not too loud or sounds fine. All right. Yeah. So maybe TChem just try the 5x5, thanks. Um, try resetting your, if you're using a headset, resetting the jack or something like that. That might do it. Rattly background. Oh, okay. Yeah, well, I'm sorry. Hopefully the recording comes through clear in case you lose the audio altogether. And hopefully my voice holds up. But the basic idea, whether um, one thing I saw was that just the other day on social media, and I'm trying to remember where I saw the image, was a 4-inch thick block of aluminum um, in a square of aluminum, essentially 4 inches thick, and I think it was probably a 12-inch in cross, or 4 inches thick and a 12-inch a 1 foot target. And um, I'm not sure who did the experiment, but they took I think it was on the order of, and I think it was on the order of about a third of a kilogram, or no, that would be too heavy. On the order of a chunk of plastic, say, about the size of this cheese that's sitting on this trap. An ounce or so, a couple of ounces in the U.S. scales, and somebody will have to help me translate that into the units the rest of the world uses. And they shot it at the aluminum at 15,000 miles an hour, and it vaporized. It melted a crater about 2 inches deep into the aluminum. Now, a floating piece of space debris isn't necessarily dangerous in and of itself unless it hits something. And so it's your product, your system, uh, more than likely has some intended function or some set of purposes. Yet in its use, is it, and it's a vague definition here. I'm kind of struggling with how to really approach it, but is it safe enough to use for its intended purpose without causing collateral harm or unintended harm? Even though it could, like this mousetrap, uh, I don't know whether it would sever a finger or not, but I'm sure it hurts. And I actually know that from experience, that getting snapped by one of these things does hurt. But that goes into a much larger question, and this is one of a good number I'll be asking here, is in the insurance business, in the legal profession, at least here in the US, in product design, whether creating an attachment for a wing to an aircraft or creating a new surgical device for use in operating rooms, or a diagnostic piece of equipment, or something that attaches to your car. Whatever the product is, at some point, one of the risks is this product may harm or kill a human. But how do you put a number on that? Does anybody know of a way that that's done? No video. Sorry, Florentine. I'm glad it's sounding good. The slides aren't moving too terribly fast, but they should be on the screen. You might have to log out, log back in, see if that works. But how do you put if we're going to talk about safety and hazards, at the end of the day, that we have to um, put a number on it in order to balance what kind of design we make and what kind of product we release. Yeah, and insurance companies have ideas of like earning potential plus a lump sum, um, experience based on airline disasters, payouts from previous judgments or settlements, and so on. Um, is a human life worth $1 million, for example? Yeah, you're right, Dennis. And there's been, and I know it goes back and forth, and there's a lot of different discussions about it. Yet it's one that every industry, um, yeah, Mark, that's a chemist answer to it. If you add up some of the trace elements, I think our value goes up a little bit. The the notion, though, is in a handful of folks were looking at past cases or past situations and settlements. Others have, but at some point, people have had to put a number on it. And earning potential is a common technique. Yet, how far out does that go? Does that make a young person's uh, life more valuable than an older person? Um, does it change with the person's inherent circumstances or not, and so on? And it gets pretty complicated pretty quick. And we're not going to spend much more time on this, but the idea is that if it's $10 million and our product has an inherent danger in it, we may spend way more time and energy making it safer. If the value is $10,000, we may choose not to do the design as much as possible. So at some point, we have to make decisions on guards, on fail-safe designs, on approaches to creating a safe product that doesn't interfere with its primary features or benefit, yet makes it um, safe. And and that's a part of why we do hazard analysis. Is we're wrestling with this: is, well, how safe is safe enough? And at the end of the day, it's not about getting snapped by a small mousetrap that may pinch your finger. It's will the wing fall off the aircraft, and how much redundancy, how much weight do we put into that, how much structural work goes into it, how much um, design consideration goes into it, is a big question. Now, a lot of the discussion around autonomous vehicles is saying, well, how do we design it such that it's going to be safe when there's no steering wheel anymore? Now, some would argue that it's safer when you take the human out from behind the wheel, while others are saying it has to be an order of magnitude safer than the best drivers. Now, I don't know what the right answer is or how that's going to pan out, but it is one of those questions that we as a society are going to have to sort out and settle. Uh, and it's an ongoing discussion. So hazard analysis is very much like that kind of discussion. Well, let's go into a little bit about what it is and how it's similar to a few other things, some of the procedures and other elements to it. And we'll circle back to some of these larger questions as we go. All right. Yeah, and yeah, Gregory, you make a good point. It's sometimes it's uh, it's the nature of the harm. If it's like the Ford Pinto or some of the more recent cases where we had ignored signals that something's not safe and shipped it anyway, versus it's a unforeseen, unforeseeable type of problem or accident. Um, it changes the nature of the culpability, if that's the right word, around a particular event. So hazard analysis is very much like an FMEA. We're looking at what could happen, what could go wrong. We're going to prioritize some actions, and it should be done with a team. It's not something that two people in the back room go off and knock out the spreadsheet, which I've seen. And you don't do that. You shouldn't do that, I should say, with FMEA either. So the idea is that it's very, very much like an FMEA, and we'll see some more similarities as we go. But here's a quick question for you. When do you do an FMEA versus doing a hazard analysis? And when is a little different question than why. So when would you do each of these kinds of analysis? handful. People are typing. One of my favorite answers when I asked this in a previous set of training I've done is early and often, right? Like voting in Chicago. I didn't notice if anybody's from Chicago, so please, it's an old joke. Um, During development, some require a HAZOP, which is very, very similar to a hazards analysis. And there's a variety of different industries that require it done during development at some stage. Yet it's like FMEA. It's an ongoing process. Early on in concept, we may be able to complete a good portion of a hazard analysis or even a concept FMEA. But as the design takes shape and materials are selected and we get more uh, firmness around how it's used or where it's used, then updating the hazard analysis and updating the design FMEA makes sense. They're very related, right? And in the regard of when you do it is early and often. It's not a one-time session like an FMEA series of standards. Yeah, but and seeing a lot of consensus about it is up early, in the early stages when you ideally still have room and space and time and resources to do something to mitigate and minimize the safety hazards. Now, what's different about an FMEA is that it's focused on safety. It's focused on not just will this product provide its intended functions, will it heat up the oven to an appropriate temperature in a reasonable amount of time, will the window controls uh, crank the window up and down at a reasonable rate within our specifications. It's not just will it work, it's will it do it with safety in mind. So like the window crank, will it stop if there's an obstruction in it that's similar to a child's finger? Or will it just keep going? And it's different than does it work in spec? Does it operate safely? Does it have ways to minimize foreseeable problems? And so this focus on safety shifts the discussion from just reliability, right? We're not looking at does it do its intended function over time within spec. It's does the functionality, the use, the storage, the transport, the disposal, all through its life cycle, does it create any hazards? Hazards being something that could harm a person or society or the environment. So it's not limited to just people. I know I've talked about harming people so far, but it's also will it harm the environment in a good number of the standards that are available on this. Now, every industry does it a little bit different. Some are required, have a pretty rigorous worksheet a defined worksheet, I should say, that goes for that industry, the medical industry. ISO standard, there's a 14,000 series that has stuff, specifics on this. Uh, Aerospace industry's got their own standards, chemical processing, nuclear industry. Um, the list of industries keeps going on. Yet it's also one that for a consumer product we should consider, right? So can our products work as they're supposed to and still be a hazard? Certainly. A lot of things that we have and use and work on, even if they just have mass, right? They have some weight. I'm looking at my glass of water on my desk that I have. If I drop that on my bare foot, it's very likely I could break my foot. Um, it's not intended to be used only where people are wearing steel-toed shoes. I have no protection against a falling mass. Yet the monitor on my screen is unwieldy to hold sometimes and move from place to place, and I don't really try to move it very often. Yet it has its inherent hazard just because it has mass and sharp edges. And so for the parents that are in the audience, you know how your view of your home changes as your child begins to crawl and to walk. The child proofing. if you look at things a bit differently. Well, that's what we're after with this hazard analysis, is to look at it from these different perspectives as to where those hazards, could come in, could show up. Now, there's huge number of hazards that are out there and available. The hard part is that as we design a product and we have a target audience for how they're expected to use it, um, the number of variables that come into play, from how familiar are they with that particular product, how adept or agile are they at handling the product, how aware of the inherent dangers are they of that product. But then also, it's how does the surrounding environment and system that are around our product interact with it. So here's where it overlaps a bit with our reliability elements. If material fatigue sets in and an unexpected load fractures our product and it becomes shattered, for example, I'm looking at my water glass, now it's posing a completely different set of hazards. It's got sharp edges and glass. If you ever dropped a glass or a ceramic mug and it's shattered on the floor, you know that some of those pieces are really, really small. And it does take some due diligence to prevent the hazard of stepping on a shard of glass. So the hazards come from the product itself, its inherent use, but it also comes from ways that we can foresee or expect it would be misused. So, not supposed to put a banana on the floor, but I have not seen a warning label saying don't put a banana peel on the floor. Although I did try to look for interesting warning labels, and one of my absolute favorites of all time was that this product is known to warp space in its immediate vicinity. Yet the list of attempts to educate the population, educate users about hazards or inherent hazards in products, it's endless in the manuals I have for different power tools, for example. Yeah, yeah. So when we're looking at, Indiana, I think your summary is right on target. Is if with FMEA we're looking at when do we lose the benefit of the particular product and its features. With hazard analysis, we're looking at its interaction with other people and the environment around it. And so damage to other assets in your plant, damage to technicians when they're trying to do the repairs, damage to the environment, say with contaminations or hazardous waste and those kinds of items. It's a different scope than FMEA. Yet it's a simple question is, well, how could this cause harm? And from there on out, it gets into a bit more complex world. So what is safety? Here's a basic definition question for you. What is safety? Yeah, and this followed on from your comment. Well, you put safety in quotes. So what is safety? Yeah, and Jeffrey, I'd say it of risk, right? Human risk, and I would add in, as some of the definitions I've done is the other equipment and assets. So even if the building's unoccupied, yet your product catches fire and burns the building down, that's a safety risk. Yeah, generally it talks about people safety, and we almost always talk about that. Um, Minimizing danger of getting harmed or hurt, and so on. It does expand out to the environment. And if we harm the environment, one line of reasoning is that if it's contamination, it's going to harm the drinking water and harm other people. And I'm just looking at safety there, and I'm wondering if I spelled that right. I don't think I did. Well, anyway, the idea is that it's thinking through what are those risks? What is the uncertainties that could cause harm? And harm in some standards is pretty general, loss or harm. And so the basic procedure, and we'll go through this pretty quick because it's very familiar to many of you that are familiar with FMEAs. It's the basic idea is well, what's the scope or focus for the study? What is the product or system that we're going to conduct the hazard analysis for? Pretty standard. What are the drawings? Do we have a prototype? Do we have a working model? Let's gather the people that are familiar with not only the product or system we're dealing with, but also people that are familiar with how it's used, where it's used, what kind of environment is it going to be in its, and ideally get some people that are familiar with actually using the product in the field in its intended locations. There might be doing, you might do a little bit of pre-training. What's the worksheet we're going to use? What are the columns? What are the terms and definitions we're going to use? How's this? It's simple things like brainstorming, no bad ideas, build on other people's comments and suggestions, don't critique, don't jump to conclusions or solutions. Some of the basics of FMEA apply to hazard analysis. One part that's interesting, though, and it's part of preparation I think should be done for FMEAs also, is you're pulling this team together for some number of hours, 2 to 10 hours or so, to do an analysis. The intent of the analysis is to do something with the results. Not just put it in a filing cabinet, but to reduce or minimize hazards. And so get your funding and support to actually take action as needed as you start. If you have no intention of ever using the results to actually do anything, in my opinion, is then you should ask why you're bothering to fill out the paperwork. So the intent is not to fill out a form. The intent is to make a safer product, and you can go with that. Yeah. Yeah, I agree, Brian. You're kind of jumping ahead of me a little bit. I think I have a slide about what's the use of a warning label in a manual. So we identify hazards, right? We figure out the brainstorming part. It's a very similar processes to an FMEA where it's, well, what could go wrong? What could cause, what could, how, for example, the water glass. I mean, if I'm doing a hazard analysis on a water glass, it could be dropped. What happens when it drops? It could shatter. It's a glass vessel. It's thinking through, well, how slippery is the surface? What happens when it gets wet? What happens when it's full? When it's got cold water poured into it or hot water? Could I make tea with this water glass, for example? Or would the heat be too much of a transition for it and cause it to fracture? A simple brainstorming, in 10-15 minutes, you can figure out all kinds of horrible things that could go wrong with your product and how it's used. But that's the start, right? This is gather as much information as possible. But part of it also is well, what are the plausible chain of events? Sure, my water glass could shatter if it's struck by a meteor, yet the likelihood of that will probably drop out real quick as just the chance of that occurring. Besides, you would have other problems if a meteor struck my desktop rather than just shards of glass from my water glass. Yet, it does include not just your product. It's how it's used and transported and carried and set up and installed and maintained. It's also what's near it and around it that could interact with your product to create unsafe events. But then it goes on, I think, in a prudent way of doing it is then seed your brainstorming with, well, how could it be misused? And then how could it be misused but unknowingly misused? I think Kirk is on the line here, and I think Kirk, you and I have talked about that. Just about any tool, or maybe it was Adam. I think it was Adam in Speaking of Reliability episodes, that it doesn't seem to matter what tool he picks up, he uses it as a hammer. I think it was Adam. I don't think he's doing that out of ignorance, that you're not supposed to use a crescent wrench as a hammer to finish setting a nail, um, but it can be done. Now, if that action causes that device to shatter or to break or to cause harm, that could be a problem. Yet, uh, it's also thinking through how people could misuse it unknowingly, and then what you can do about that, and then what you after, and then like it or with FMEA, like it or we prioritize. Now, what you hear, there's typically two scores: the probability of occurrence, like a meteor hitting my water glass, is exceedingly rare, yet the chance of it slipping out of my hand in handling it in and out of the sink or in and out of the dishwasher or in and out carrying it up the stairs is reasonably high. Is and then what's the severity? What is the path there to harm? How much harm could it do? Now, a broken water glass is not going to harm my neighbors, yet there are things that if my house caught on fire, that it could harm my neighbors and firefighters and so on. So different severities, and very much like a FMEA, is each of the standards that are associated with these provide um, different scales and ways of weighting these things and so on. In some set these things, criteria is that it has to have no hazards above a particular score. And so it depending on your industry and your standards and your scoring algorithms, there may be different rules around these, but it's very much like an FMEA. What's the chance of it occurring, and then what's the effect or the severity, and put a score to that. Very, very similar to FMEAs. Now, very quickly, if you've ever done one of these or an FMEA, it's very easy to come up with hundreds, if not thousands, with a little bit of concerted effort, of issues or problems. And there might be 30 or 40 that are, yeah, these are likely and have enough severity that we really need to do something about those. Yet, how do you decide how deep in that list to go? Whether it's an FMEA or a hazard analysis. Yeah, so we prioritized, Jeffrey, and we got a list, right? We have the scoring and the risk priority number that gives us a rank ordering of the things that are topping out the list of most common or most likely to occur and or most severe, or in some mix of those. But let's say we have 30 things on the list. Each one's going to cost us at least $1,000 each to solve. We have, how far do you go? We have, 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 and I'm just using a round number there. But as you know, some things will be simple to solve. Some will be really difficult to mitigate or minimize the hazard. And some may be technically not possible. How far down this list do you go? Yeah, I agree, Jeffrey. Yeah, it's going to be how risk tolerant your organization is, and to use a tolerant management term there. To tolerant. Some industries have criteria and standards. Others do it by engineering judgment and management approval, saying we're going approval to balance the cost the benefit of using this product, uh, and minimize the risks to a fixed level. Other do it just inherently. There's no overt discussion or decision point. Now, I much prefer products that are well thought out and uh, balanced and reasoned, saying, here's our time and resources, here's our intended audience, here's our expected, here's a series of risks and hazards we're facing, here's what we can do, here's what we're trying to do, here's what we're evolving the product to do. And it's still a point, though, where you're going to have to say we have to ship it. Point, though. So you're right, Brian. Like in the FMEAs, the ones with the highest severity need to have some attention, and it's always going to be a gray area, and it's working well with your team, with the key decision makers that are signing off on that this is an acceptable risk given our technology, time, market, and so on. It's always going to be an uncertain spot in these processes. So you should, well, I guess you could look forward to that. All right. So what do? You get this whole list. What are our options? So what can we do? What do you about it? Now one option is to say, oh, okay, those risks exist. Buyer beware. Now that doesn't fly very far in the U.S. It also isn't good for your products if it's. I think there was a Dilbert cartoon that it exploded spontaneously and sent out metal darts in every direction. The series, goes over the top sometimes in its cartoon, yet knowing the risks that are involved with the product, are they appropriate for the intended benefit or use of the product? A surgeon's scalpel is inherently dangerous, but in the hands of a surgeon, it's life-saving. So are the circumstances around its use and intended use appropriate for the hazards it presents? And so here's a few things that we can do and should be thought through on as many as you can get the time and resources and is appropriate to do. And that's the gray area in this whole process. So number one, just like an FMEA, let's design it out. If there's a hazard and we can eliminate the possibility of that hazard coming true by design, we can do, if that is practical, and that's that gray area again, design it out. Just eliminate that from happening in your product. Now, the design out part is a balance of what is the intended function of the product, right? What is it supposed to do? And if I put on too many guards, or if I blunt the edge of a surgeon's scalpel so that it doesn't cut people inappropriately, the surgeon loses that functionality. So that's not really an option there. Yet, if the hazard is it slips and it cuts inappropriately, then creating a structure that is better or easier to hold may be a design feature that we put into it, reducing the chance of occurring. But where possible, change the material, change the design, change its interactions with the environment, such that that chance of that occurrence of that risk manifesting itself, or that hazard manifesting itself, just goes away. Now, that's why we put in flame retardants in a lot of electronics, is that we have hot devices in an enclosure, and if it gets too hot, it will self-extinguish. A lot of the flame retardants we use just squelch the fire right at the source. And that's a design choice. They're expensive to add into the epoxy overmolding, yet it's just trying to eliminate the chance of this catching and going further in starting a fire. So lots of design choices. Those are by far the best option. They can be expensive, or they can be just no problem whatsoever. It may be inherently the way things are designed, yet it's part of your first line of attack at minimizing hazards. The second part is to create something that reduces the severity if something goes wrong. If we have the chance of occurrence that it's going to, say, my water glass, if I drop it, if it was made out of Pyrex, it could handle hot water versus cold fairly easily. It's probably more robust. I could make it thicker so that it's less likely to shatter, uh, more likely to break my foot if I try to stop it with my foot. And it becomes a balance. What's the likelihood of breaking that chain of events such that if something's going wrong, that it doesn't cause more harm or causes the highest severity type of hazards. Now, I chose this image in particular because um, that device that rope is going through is just a loop. It goes around the base of his harness. There's a little carabiner there, and the rope loops around that, and it goes in and out of that. Uh, we call them air traffic controllers, ATCs. Uh, I'm not really sure what their true name is, but they're used in rock climbing as a belay device. And when you're using it appropriately, you can change the angle of that rope such that the rope will bind. It'll stop moving. Your body becomes the anchor. But if you let go of that rope, this person has two hands on it. If you let go of that rope, it'll just go flying right through that device. There's no automatic brake. Where if somebody is falling and you don't have your hands on the rope, they're going to fall. And it's a real hazard. Now, it's lightweight, it's easy to use, it's got lots of features if it's used appropriately. There's another similar device that's been invented over the years, and it's called a GriGri, and it has a fail-safe device in it that makes it a little more awkward to set up and to set up the rope within the device. But if you let your hands go, it will lock. It will just stop the climber from falling. So it has this fail-safe design in it. It costs more. It's more cumbersome to use. And so you still see these devices in use because of that trade-off of perceived risk versus benefit. And so oftentimes when we do fail-safe designs, they add complexity or cost to a product. Now, in some industries that's accepted, in some industries it's expected. In most designs, we have options and considerations of how to create a fail-safe design. And so it's a second level of option. It focuses on reducing the risk of a sequence of events from happening. And in this image, if you let go of the rope, it just goes. Is this going to, if they're falling, they fall. Whereas if it's a GriGri, if you let go of the rope, it'll lock. The fall will be interrupted. So another realm in the options, and it's interesting that, and in the hazard analysis, we do not put in the detection column like we do in FMEA. We don't look for those signals that indicate that there's a problem occurring. Yet one of the mitigation strategies is that if you can detect an impending hazard and create an alarm or a warning for it, it's an option. It's the third option. It's not the preferred. Yet many of you are very familiar with products that have warnings and alarms and signals that give us indications of something else going on. It is an option. It's not the favorite option. Yet the least favorite option by far is just put a warning label on it, right? Or we're going to do some training. Some of these things are done. They're done very quickly, and they're usually, well, training's not always the least expensive, and warnings aren't always the best ones. I did find an image for a electrical cabinet in a factory that had a warning label on it saying, opening this electrical panel will cause death and a $50 fine. Now, I don't know if they did a study or if that was, you know, just add insult to injury after you get electrocuted, but then your state gets a fine on top of it. Yet it sure caught my attention. We have so many labels, so many warning stickers, so many codes and symbols out there that there's a bit of fatigue there. And so I think somebody mentioned earlier is just adding it to the manual is yeah, you keep a lawyer happy and sell another page of your manual, but it doesn't really work. I doubt it. Right. So it's a basic system, right? The hazard analysis and what we do. Yeah, yeah, cut the white wire. Yeah. I know that's from a movie. I'm just trying to remember which one. So generally, the idea is the hazard analysis is done. It's very similar to an FMEA, which many of us and many of our teams are very familiar with. And it's a different focus. That's all. It has some of the same issues, whether we get a team together, issue and how well we focus on the issues that team on the task at hand and do effective brainstorms and think through it from different points of view, and then finding the resources and follow through to minimize the hazards that are presented. Now, some will be obvious. Some will be, we have to fix that before we can ship it. Some will be so trivial, like the meteor striking my water glass, that we're just not going to design for that. It's just not an option. Where it becomes interesting is in that area where you're working down the list and they're not immediate present danger to all involved in the environment. It might happen and it would be bad if it does, but not terrible. Do we fix that or not? Do we address that? And every circumstance is going to be different. But I think the point of this analysis and the idea of why so many organizations and industries expect us to do this is that it's a chance to step back and with our team, think through how our product is going to interact with the folks using the product and moving it, installing it, but also the environment and the systems that they're in and around. And have we thought through those basic questions of what happens when something bad is occurring, bad being unsafe, and does it feel safe? Is that even possible? Is it sold and managed appropriately to the correct audience, that's a correct set of customers that are going to use it appropriately? Is it going to cause harm in an unexpected way? Now, this is one of those questions of how can we find out what we don't know we don't know? Well, like FMEA, hazard analysis is one of those tools to try to chip away at that, to try to look at our product like a parent would when your child is just starting to walk. You see the coffee table in a completely different way. Do the same for your product. That's the point of hazard analysis, is look at it in a different set of eyes, different set of perspectives, from it being misused, being mishandled, being used inappropriately, but also how is it regularly used and what could go wrong there, and what kind of harm could come from that. What can you minimize or mitigate? And so the basic idea is it's focused on safety, which is harm to people, society, environment, other equipment, and assets. It's very similar to an FMEA. It's a team-based, it's brainstorming, it's prioritization, and it's minimizing the scoring on those prioritizations. And then we eliminate or reduce or mitigate those risks, those failures. And at some point, same for your make a decision. Is it safe enough to ship? Is it? Have we thought through it with due diligence to make this product appropriate for the market we're sending it to? And it's an ongoing process. It's not a one-time and file it, which I think is one of the greatest. It's that's not terribly useful, and you know that. But stepping back and taking the time to think through how your product or system is going to interact is some industries it's regulated and required. Regulate. In other industries, it's just a prudent step to take. Yeah. All right. So let's see. I pull up my last slide here. There's a couple of links and stuff. Let me pull up the links and stuff that we have. Now, most of what I presented was pulled out of same for your Carl's book, Effective FMEAs. You can find a link to it in the lower right corner. I also mentioned the podcasts. We're getting really close to going over 500,000 downloads on the various podcasts. You have to rely for your ability. You have .fm. Relying for your everybody. You have for your listening to those, but also your so I'll pause here for a second and see what kind of questions we have. Any thoughts? Yeah, you know, Graham, and that was one of the things Carl brought up is that in his book is that they're often done at a similar time frame, and one could argue doing the FMEA first, which includes looking at the severity, the safety type things, of what your product your design can do. For example, if something goes wrong in the design, and then I'd say dovetail that is the appropriate word, is use some of the information and insights from the FMEA, but now look at it from different points of view on its hazards as it's used and misused in various ways, with more of a focus on the safety side of it. FMEA includes safety, reliability, availability, functionality, all these other ilities. And then it's step back and look at just the hazard side, the safety side. So I think they work well together. Different sessions with different focus, maybe the same people. Well, appreciate it, William. That's why I'm doing them. And I'm hoping to take these recordings and build a kind of library of these fundamentals as the intention I'm going after.